let's talk about something called recursion. For now, let's create a program called countdown. And let's think about how we would create a program that counts a number down from, say, 5 to 0 and then prints blast off. Well, we would import time. Let's say we begin at 5. And certainly, we would create a loop. We would want to iterate on the value of n. So as long as n is greater than or equal to 0, we do the following. N is subtracted from itself by 1. We take a second to sleep. And then we want to print blast off if n is equal to 0. Certainly, this is how we would create a program that begins at 5, prints 5, 4, 3, 2, 1, and if n is equal to 0, instead of printing 0, it prints blast off. And there we go. So we see it working. We call this method of looping through a particular value, we call it iteration. What if we don't want to use a loop? How do we iterate then? How do we loop without a loop? Well, there's something called recursion. Recursion. And recursion is simply defined as follows. Having a function call itself from within itself. And how does that help us loop without using a loop? Well, let's see. First, I'm going to comment all of this out so we have it kept here as reference. And let's begin a new program from above. Import time again. Then we do a function call. Let's begin at 5. Now we haven't created the function yet, so let's do that. Let's say that the variable that gets input into the function is n. This means that n needs to change each time we call the function. It works in similar vein to the loop, where n is different each time or each iteration of that loop. Here, n is going to be different every time we call countdown. But we only called countdown once. We only called countdown from line 6. So what do I mean by each time we call countdown? Well, why don't we just call countdown from within itself? We subtract n by 1 and then have that smaller value be input back into itself. Then, what happens if we run this program? Have it print n before we recur by counting down. Well, what happens is that we essentially enter an infinite loop. We don't have a way of breaking or ending or returning from the recursion, so it just the function keeps calling itself from within itself. So n goes from 5 all the way to negative 991, at which point maximum recursive depth has exceeded. We're not allowed to recur too many times, because every time we recur without actually ending the function, that takes up a lot of memory. So we're not allowed to exceed a certain amount of depth. So what is going on if we were to illustrate it? Well, what's happening is we have a program, which is the program that exists outside of any kind of function, called main or global. Let's just call it main for now. And what's going on is every time we begin main or begin our program, it goes down a list of instructions until it um, reaches the end of those instructions, at which point the program ends. Right? But what happens if in the middle of main there is a function call? For example, what if we do a function call to countdown? Well, here we have countdown at 5 when n is equal to 5. And essentially, a function is sort of a miniature program within your program. So countdown is going to read its list of instructions until those instructions run out, at which point the program ends and it returns back to main. So when we call countdown 5 from main, main is paused until countdown completes. Countdown has its own list of instructions, and when countdown completes, or any function completes, it returns back to the point from where we called the function. But what's necessary to note is that main is paused until the function completes. What if main calls countdown, but countdown does not complete? Countdown has another call to countdown. So countdown then is paused until countdown when n equals 4 completes. So countdown when n equals 5 is paused until countdown 4 completes. But countdown 4 has a function call to countdown 3, doesn't it? So then countdown 4 is paused until countdown when n equals 3 completes. And we can see that as a result, it goes on infinitely because this pattern continues. None of the countdown functions ever actually end. And this is what we refer to by depth. So as we go to the right, this is depth. Depth within main is what we might say, or depth here is 0 because it's the first call to countdown. Depth when countdown equals 4 is a depth of 1 because we're essentially one function within countdown. Then countdown 3 is depth of 2 because we are, in a sense, 2 functions past the first call to countdown, and it continues kind of like that. So that's what we mean by depth. And if depth gets too large, we have too many open functions, and then the program has to end. It doesn't have enough memory to continue going, to continue opening these miniature functions within themselves over and over. So then how do we end it? Well, here's how we end it. Let's go a little further. Just complete what we've kind of begun here. Countdown 2, countdown 1, countdown 0. So this pattern should continue until we reach countdown where n, which is the input local variable, is equal to 0, at which point we want a way to make sure that it does not call itself again. We don't want countdown 0 to call countdown -1. We want it to end the function. And how do we do that? Well, prior to this call to countdown -1, we want to return. We want some way to return from the function prior to the call to countdown -1. So we're not allowing it to recur any further. We're returning before it can recur. And if we do that, well, then the function will end, certainly. It will not recur on itself. It'll end. It'll return back to countdown 1. Countdown 1 will continue until it ends its program, its function. It returns to countdown 2. Countdown 2 continues until it runs out of instructions. It certainly doesn't have any more recursive calls after the one recursive call. That returns to countdown 3. It ends its list of instructions. Countdown 4. Countdown 5. And finally, it returns back to main, at which point the program is allowed to continue until it ends. So this is our objective, is to create something that looks like this. And what is it called when a function, we have some kind of if statement that checks for a return prior to the recursion? We call that the edge case or the base case. What that means is that when n is 0, that's our base case. That's our edge condition, our base case. When n is 0, we don't want to go below n equals 0. So let's go back to our program and see how we can resolve that. So here we are back in the program. We see we have a recursive function right here. Countdown is calling itself and sending a smaller n value each time. We want to put our edge case before the recursive call because we want to possibly return before the function is allowed to recur. If it's allowed to recur, then it would just keep recurring. So what do? Let's do this. If n is less than or equal to 0, we're going to blast off. Then we're going to return. Just to see what's going on, let's put in a time sleep. Well, there we go. Finally, the countdown when n equals 0 is allowed to return. In a sense, it rewinds itself back to main because all of the previous countdowns are allowed to end because they return when their list of instructions completes. So once we reach the base case, all of the functions are allowed to rewind and we return back to main. There's really two parts to a recursion. There's the part that's prior to the recursive call and the part that's after the recursive call. The part that's prior to the recursive call will happen in the forward direction. For example, let's print the following. Going down because we're going deeper into the recursive cycle, we're getting more depth. So let's say we're going down because we're entering the recursive structure. Then, after countdown, let's put a time sleep and following. We're going out. Line 5, where we're going down, will call prior to the recursive call. The print on line 12 will print after the recursive call, or after the functions are allowed to start returning and rewinding. So what does that look like? Deeper, we're recurring more and more depth, we get blast off, we return. Now the previous functions start to end. They start to end because we see the print statement that occurs after the recursive call start to be run. Then, once the last one is returned, we return to main ends, and then the program completes. Let's create a new program called triangle. Let's have it print a triangle out of stars using recursion as opposed to iteration or using a loop. I'll call this program use recursion to print a triangle. So first, we begin with a starting condition. Let's begin with the value 10. That's going to represent how many stars make up an individual line of our triangle. Then we need some kind of variable, a local variable that's going to change a little bit each time we recur. Let's put a base case, because the base case needs to be done before the recursive call. Otherwise, we will just recur until maximum recursion depth is reached. So as long as k is 0 or more, we keep recurring. Otherwise, we return. Let's loop through k and print so and so many stars on the same line. Then we'll print a new line. Finally, we're going to recur the function back on itself. So on the first recursion, k will be 10. So that means 10 stars are going to be drawn on the first line. On the second recursion, k will be 9, so there will be 9 stars, and 8, 7, 6, and you get the picture. So when we run this program, there we go. We have 10 stars in the first function call to line, 9 stars on the second function call to line, 8 stars until it reaches 1 star, at which point when k is less than 0 here, we start returning. We know we're returning when the following print statement is hit. If we put this line after the recursive call, then that means base case has been reached and we are now rewinding. There we go. We get our upside down triangle, and then we have 10 print statements of going back because 10 functions are returning. Okay, so now let me ask you this. What if we want the program to print a triangle that is not upside down but right side up? What is the fastest way we could do that without adding a single new line? Well, let's take lines 8 and 9, where we're printing the lines. Let's delete them. Instead, put them after the recursive call. So because now the stars are printing after the recursive call, the first time lines 10 and 11, this loop here, where we're printing the stars, the first time that instruction is reached is when k is 1. Then the function returns, it goes back up a level, and now k is 2. And k is 3, k is 4, k is 5, until k is 10, at which point the initial call to line ends, and then the program is allowed to end. So just by moving the for loop where we're printing after the recursive call, we can get this to happen. Now the triangle is right side up. That's because we're printing it in reverse. We're printing it after the recursive call.